cow, they pretty much cut all of those muscles off at their attachment points. So I can't really ask you about the muscles on the real eye, simply because they've all been cut. One thing that is nice, though, is that you can see what's left over from the adipose tissue that actually surrounds all of our eyes. The truth is that our orbitals are relatively large spaces that are larger than our eyes and muscles and the nerve, and so there is a good bit of this packing material that helps to fill that space in such a way that you still have, the ability to move your eye quite easily, and at the same time helps to also cushion it. Now, if I'm looking, I can see in amongst all of this fat, it's been cut fairly close, but that right there, you can see, is the optic nerve. Okay. That little bitty circle right there is the optic nerve, and it should, in fact, have gone all the way out. They just cut it fairly close. All right, right there. See the little circle?
Oh, yeah.
Okay. Now, on the outside, we can definitely still see the fibrous tunic. This portion of the fibrous tunic is the what? Sclera. And this portion is the cornea. Okay, now two things. One is that you'll notice that the cornea is a bit misshapen. I can make it kind of go back to its proper shape by pushing it on a little bit. But with that shape, do you think light would go to the retina in an appropriate manner?
No.
No. This is one of the reasons we have aqueous humor in the vitreous body, to make sure that in our eyes the cornea stays that nice round shape to allow light to pass like it should. The other thing you'll notice about this cornea is it as clear as your model?
No.
No. In fact, if the cow, when it was alive, had a cornea like this, you know what it would see? Well, it would be able to tell when it's light and when it's dark, but that's about it. Okay? The truth is, though, is that this cow did not have cataracts, although cataracts would look very similar to this. Instead, the cornea here has basically just, it's an artifact of the formalin, let's put it that way. As it sits in the preservative, it goes from clear to this very, cloudy sort of appearance. It's not what you would expect in a living eye. All right, so what I'm going to do is I am going to cut this sucker open. Thank you, sir. All right. Going through the posterior cavity of this eye. All right, now, if this was a real eye, freshly plucked from the head, it is a real eye, but if it was freshly plucked from the head and not just preserved, the liquid coming out would be the aqueous humor. The liquid coming out of this one, though, since it's been sitting in the formalin, is in fact just formalin. Okay, so what I'm going to do is I'm going to open that.
Looks like a clam. If anybody wants the video, just write your email down. I'll send it.
Okay, and in doing so, it will allow you to visualize the gelatinous-like mass. Definitely not a hard piece of plastic like is in the model. It definitely looks like someone simply went, I know, I love that joke. What can I say? All right.
The vitreous.
All right. Again, the idea is the vitreous body in a living eye should be clear. This is a little bit more cloudy and discolored than you would expect to see, because you want the vitreous body to be as clear as possible to allow light to come through unhindered. Okay, so this is basically just, again, discolored because of the formalin. All right. Now, on this side, you can see that there is a difference between this white sheet of tissue and the material behind it. This white kind of light sheet of tissue should be the what? Come on, come on, come on. No. Let's put it this way. Light would be hitting this stuff. No.
I'm not sure where you're pointing to. Go ahead.
The light tissue right there, that light tissue. It's the retina. Okay, so that light sheet of tissue is the retina and would represent the vascular tunic. All right, now it's very difficult to tell exactly where the fovea is, okay, because of the fact that I've separated out the eye. So guess what? If I can't identify it very readily, I didn't say it, but there you go. Okay. What you can see, though, is can you see where the retina kind of puckers up in one particular location? Where it's puckering up at, that's because it's about to go through the eye and come out the optic nerve. That puckering area is, in fact, the optic disc. Okay? All right. On this side, let me clean out the rest of the vitreous body. All right. And with it has come this structure. It's a little hard button of material. This is, in fact, what?
The lens.
The lens. It should not be this discolored. Okay. Again, it only looks like this because it's satin formalin. The other thing that happened when it's satin formalin is it got stiffened. This is very hard. It would be very difficult for the cow to change the shape of this. This one would essentially be in such a shape that it could only focus at a set distance. A real living lens should be relatively pliable so that you can change its shape to change its focus. All right, let me clean out some more of this vitreous body. All right, and when I do so, what you're going to see is it looks like the underside of a mushroom. You can see all the, let me get that out. You can see all of the little ridges. That right there looks like the shiny black underside of a mushroom. Okay, when you get up close, it's a little easier to see. All right, the idea is that all of those little ridges represent the ciliary body. Okay, so the ciliary body is all of those little black ridges surrounding this area. Okay, now, can you see the iris from this side? Yes. Will I ask you about the iris on this side? No. No, I won't, simply because I don't want to confuse anybody. So if I pinned it in the black over here, ciliary body. All right, if I want to show you the iris, what I'm going to do is I'm going to cut a window through the cornea. By the way, can you guys hear the crunch? Yeah. Okay, that crunch is in part due to the formalin, but also due to the fact that there are proteins called crystallins that form part of the cornea. It's part of the reason it has such good optical properties, but it's also why it has such a crunch to it when you cut through it. All right, now what I'm trying to do is, again, cut a window to allow you guys to see the iris. Okay, come on. Okay, do me a favor, ma'am. If you could, there you go. Thank you. Okay. And now that I've opened up that window, you guys can see there is a black ring of muscle surrounding where my glove is at. My glove is actually at the pupil, and the black ring of muscle that you can see now that the window is moved, that's actually the iris. Okay, so you can see the iris, or I would ask you about the iris from this side. Okay, now if memory serves, that should be all of the pieces that are on the choroid. Okay.
Can you show the black rings through the window again, the iris?
There?
Okay.
Okay. The black that is behind the kind of pale yellowish retina, that's actually going to be where you find the choroid. Okay. All right. One last thing to note is in the cow eye, you'll notice there's a very shiny pigment behind the retina. In humans, we don't have that. And the reason for that is that basically we don't see well at night. That shiny pigment on the backside of the retina allows cows and other animals to see very well at night. If you've ever gone down the road and your headlights hit the eyes of a deer or of a cat or a dog, you've seen that shiny kind of like devil sort of eye going on. Yeah, it's basically just that same pigment. It allows them to see in lower light conditions. If you catch a human's eyes in your headlamps, what does it look like?
Red?
Yeah, it's red because we don't have that pigment, and instead you see the blood vessels that are actually in the retina.
So what's the pigment called?
Offhand, I don't remember.
Okay.
Yeah, it's not important because it's not on your
Okay, good.
your list.
If it's like a nocturnal animal that only sees at night.
If it only sees at night, its eyes are going to be relatively big, and it will have a ton of the pigment. Because these are animals that are active both in day and night. While it's got pigment, it's not covering the entirety of the back of the eye, just a section of it, typically on one half of it. Okay. Yeah, I think so. Okay, I've got one eye here that's dissected. Also an eye that was dissected